Bismillahirrahmanirrahim. I am Riaz Hussain Junaidjo and I am delivering the video lectures for the course of Applied Electricity and Electronics. The course code is CEE103. This course is being offered by the Department of Electrical and Computer Engineering, Computer University, Islamabad Wagh campus for the semester of fall 2020. This is a series of lectures and today we are going to discuss lecture number 16. In total, we'll be discussing 32 lectures and today's topic is problems on nodal analysis. In previous three lectures, we have discussed the nodal analysis. We have seen the theory behind the nodal analysis. We know that we have to use Kirchhoff current law to apply nodal analysis. We have seen that how we can use the nodal analysis for the circuit that contain only current sources, and we have seen that how we can simplify the circuit that also contain the voltage sources. So let's see the problems for the student information that these course lectures, slides and videos are being prepared from the textbook of Fundamentals of Electric Circuits. The author is Alexander Sadiko, and these lecture slides and problems are taken from the third chapter of the textbook, that is methods of analysis. So let's see some problems related to nodal analysis. So problem is, use nodal analysis to find V naught in the circuit shown. This is the circuit. In this circuit, we want to apply the nodal analysis to find the V naught, that is voltage across 4 ohm resistance. But you have to use the nodal analysis. So remember that before applying nodal analysis, we have to see that how many node voltages are present in the given circuit. You can see that this is the node number 1. Here there are 3 branches connected. This is node number 2. Here there are 4 branches connected. So there are 2 non-reference nodes and this is the reference node. We cannot take this as a non-reference node because there is only 2 branches connected. This cannot be considered as a node voltage. So we have now identify the number of node voltages and nodes here. So next we have to see that what are the current directions in each branch of the circuit. So starting from this branch, we can see that here current direction is already given, that is 5 ampere current source, and this 2 ohm resistance is connected between V1 and let's call this as V0. So current direction can be from V1 to V0. So this is the direction, and here we have also shown the current direction from ground to V1. We can also show from V1 to ground. It's up to you. And this is the 4 ohm resistance is connected between V0 and ground. So this is the current direction. Here again we have shown the current direction from this branch to this branch. So we have actually current direction in each branch. Next we can apply Kirchhoff current law, and one more thing, you can see that here there will be no super node because there is no voltage source that is connected in between 2 reference nodes only. This voltage source is connected between actually this node and ground. So obviously this is connected between a reference node and a non-reference node. This is also voltage source is connected between ground and a non-reference node. So there's no there's no need to construct a super node. So let's apply Kirchhoff current law and Kirchhoff current law at each node. So again you can see that there are 2 unknowns, V1 and V0. So we need to construct 2 equations, 2 linear equations. So at node number 1 we can see that there is 1 incoming current and there are 2 outgoing currents. So at we know that according to KCL, sum of outgoing current should be equal to the sum of incoming current. So outgoing current is current in 2 ohm resistance, that will be V1 minus V0 divided by 2, and this current in this branch is 5. So V1 minus V0 divided by 2 plus 5, that should be equal. Current in this branch will be 40 minus V1 divided by 1. So we can multiply with 2. So and also we can collect the like terms. So equation will be V1 plus V naught is equal to 70. So this is equation number 1. At node number 0, here node voltage is 0. In this actually node there are 4 branches connected. So we can see that this is incoming current, this is incoming current, this is outgoing current, and this is also actually outgoing current. So we can say that sum of the incoming current should be equal to the sum of the outgoing current. So current in this branch is V1 minus V0 divided by 2, and current in this branch is 5. So V1 minus V0 divided by 2 plus 5, that should be equal. Current in 4 ohm resistance is V0 divided by 4 plus current in this branch is actually V0 minus 20. So this will be V1 plus 20 divided by 8. So we can simplify and put this equation into standard form. So standard form of this equation will be 4V1 minus 7V0 is equal to minus 20. So this is equation number 2 now. So now we can say that we have two unknowns and we have two equations. So we can simultaneously solve these equations. Since we want to find only V0, so we need to solve for V0 only. So V0 is actually 27.27 volts. So we don't need to solve for V1. So this is the value for V0. Again, you can see that the solution of these two equations can be done in any of the method. That is, you can use the Cramer's rule, you can use the elimination method, or you can use Gauss-Jordan Gauss elimination, or you can also use the calculator, as we have mentioned in the class as well. So V0 is equal to 27.27 volts. Let's see another circuit. The problem is obtain V naught in the circuit shown. So this is the circuit. Again, this is a very easy circuit. In this circuit, there are two voltage sources present, and you can see that voltage sources are present in between reference and non-reference node. This is also voltage source present, that is between V0 and this point. So we don't need to construct any kind of super node here, and also we can see that there is only one non-reference node, that is this node. Here three branches are connected. So let's suppose that voltage at that non-reference node is V0, and this is the ground node. So we can apply Kirchhoff current law at this node. We can see that there are three branches connected. So we must know the direction of each current. So current in this branch is from V0 to ground, and current in 6 ohm branch is also from V0 to ground, and current in this branch is also from V0 to ground. So this means that as seen from this node, there are three branch currents, and all these three branch currents are actually outgoing currents. So we can say that I1 plus I2 plus I3 should be equal to 0. According to Kirchhoff current law, sum of the outgoing current should be sum of equal to the sum of incoming current. So if there is no incoming current, so I1 plus I2 plus I3 should be equal 0. So now we have to find the equation for I1 using Ohm's law. You can see that I1 is current in this branch. So since we know the resistance in this branch, so we can say that I1 will be equal V1 minus 12 divided by 4. Similarly, equation for I2 will be equal to V0 divided by 6. And similarly, current for equation for I3 will be equal V0 minus 10 divided by 2. That should be equal to 0. So we can simplify. LCM is actually 12, so we can multiply with 12. So this will be 3V0 minus 36 plus 2V0 plus 6V0 minus 60 is equal 0. So in this case, we can collect the terms for V0. So 3V0 plus 2V0 50 plus 6V0 11V0. So minus 36 minus 60. So this will be 96. So V0 will be equal to 8.727 volts. So this is the value of the V0 that is required. So now you can see that actually if we use simple KVL and KCL, there will be too many equations, but if we use nodal analysis, there will be one equation that we have solved. Let's see another problem. Obtain V1 and V2 in the circuit shown. This is again very easy circuit. In this circuit, there are only two current sources present. So, just as mentioned, nodal analysis is the best choice for such circuits where only current sources are involved. Next, we will see that how many node voltages are nodes are present. So you can see that this is node number one, this is node number two. So there are two non-reference nodes, and this is the reference node. So it means that there will be two unknowns V1 and V2. Next, we'll be indicating the current direction according to passive sign convention. So current in this branch is known, current here is also known. So current in 10 ohm resistance could be from V1 to ground or from ground to V1. Similarly, current in 5 ohm resistance will be from ground to V1, and here let's suppose from V2 to ground, and from current in 2 ohm resistance is from V1 to V2. So now we have indicated the current directions. So now we can use the Kirchhoff current law at V1 or node number 1 and node number 2. So at V1 node, you can see that there are three branches connected. So this is incoming current, this is incoming, this is outgoing, and this is outgoing. So there are two incoming currents and two outgoing currents. Similarly, at V2 node, there are one, two, three, and four branches connected. This is incoming current, outgoing, incoming, and incoming. So there are three incoming and one outgoing current. So we have to apply KCL one by one. Again, you can see that here there is no need to construct a super node. So this is the circuit. So at node number 1, actually just mentioned that there are two incoming current and two outgoing current. Current in 10 ohm resistance will be 0 minus V1 divided by 10, and current in 5 ohm resistance, this is also actually incoming current to V1. So this will be 0 minus V1 divided by 5. So that should be equal sum of the outgoing current. 6 is the outgoing current. So 6 plus V1 minus V2 divided by 2. So we can simplify this equation using LCM and collecting the like terms. So equation will be minus 8 V1 plus 5 V2 is equal to 60. So let's call this equation as equation number 1. So we have constructed equation number 1. Now we'll be constructing equation number 2 by applying KCL at node number 2. Again, just mentioned there are three actually outgoing current. This is out in fact there are one, this is incoming current, and incoming current. So there are three incoming and one outgoing current. So sum of the incoming currents should be equal to the sum of the outgoing currents. So applying KCL at node number 2, current in 4 ohm resistance will be V2 divided by 4. So this is outgoing current. So this should be equal sum of the incoming currents 3 plus 6 plus current in 2 ohm resistance. So this will be 3 plus 6 plus V1 minus V2 divided by 2. So we can take the LCM and collect the like terms. So standard form of the equation will be minus 2V1 plus 3V2 is equal 36. So let's call this equation as equation number 2. So now we have the two equations for two unknown variables. So now we can easily solve simultaneously. We have V1 is equal 0 and V2 is equal 12 volts. So finally we have found the value for V1 and V2. So you can see that V1 is 0. So this means that there will be no current in 5 ohm and 10 ohm resistance actually in this case. Next, apply nodal analysis to find the node voltage V1. So this is again a simple circuit. We need to find the node voltage. In this case, we have actually one non-reference node, and this is the reference node. At this non-reference node, there are three branches connected. So let's suppose that current in this branch is I1, here current is I3, and here I2. So you can see that I1, I3, and I2 are actually outgoing current. So applying Kirchhoff current law at this node, we have I1 plus I2 plus I3 is equal to 0. So now we can write down the equation for I1, I2, I3. Again, you can see that since voltage sources are present and these voltage sources are not in between two non-reference nodes, so we can easily apply Kirchhoff current law. Or we can also see that since resistance in each branch is actually given, so we can use Ohm's law. So equation for I1 is actually V1 minus 12 divided by 100, plus equation for V2 is V1 minus 0 divided by 200, that is V1 divided by 200, plus equation for I3 is V1 minus 6 divided by 300 plus 100, so that should be equal 0. So now since only one unknown is involved, so we have the one equation, so we can actually collect the like terms. So v1, so this will be 1 upon 100 plus 1 upon 200 plus 1 upon 400 minus 12 divided by 100 minus 6 divided by 400 should be equal 0. So we can take the LCM. LCM is 400. So this will be 4 plus 2 plus 1 divided by 400. Multiply by V1 is LCM is here 400. So this will be 48 plus 6. We can transfer that to right side. So this will be positive term. So V1 will be equal 54 divided by 400 multiplied by 400 divided by 7. Or V1 will be equal 7.71 volts. So this is the value for V1. Let's see another problem. Determine VAB, and the current flowing through 100 ohm resistance in the circuit shown. This is the actually circuit that we want to solve. Want to find a voltage at A and B points, and also want to find the current flowing in 100 ohm resistance. And we have to use nodal analysis. Before applying nodal analysis, we have to actually take care that how many nodes are present. Obviously there are two nodes, node A and node B. So let's suppose that voltage at node A is VA and VB is the node voltage at point B. This is still, remember that node B, this is node B, this is node A, this is node A, this is also node A, and this is the ground. So next we have to actually show the current direction in each branch of the circuit. Starting from this branch, we know the current, and here current is actually at 800 milliampere. So this 100 ohm resistance is connected between point A and B. So let's suppose that current direction is from point A to point B. Here this is also actually current resistance is connected between A and B points. So here let's suppose current direction is from A to B and resistance is 50. Here current direction is downward because this resistance is connected between non-reference and reference node. Here current direction is already given. Here let's suppose current direction is from node point B to ground, and here already current direction is given. So you can see that actually in this circuit there is no voltage source involved. So this means that we can easily apply nodal analysis, and there will be no super loop here, in fact super node here. So applying Kirchhoff current law at node A, we can see that at node A there are 1, 2, 3, 4, 5 branches connected at node A. This is actually outgoing current, outgoing current, outgoing, and incoming. So there is only one incoming current and 4 outgoing current. So current equation for a current in 10 ohm resistance will be VA divided by 10, plus equation for current in 50 ohm resistance will be VA minus VB divided by 50, and plus current in this branch is 2 ampere, plus current in 100 ohm resistance will be VA minus VB divided by 100, and that should be equal 800 milliampere, because this is the only incoming current. So this means that this should be equal 0.8. So now we can multiply with 100. So this will be 10 VA plus 2 VA minus 2 VB plus 200 plus VA minus VB is equal to 80. And we can collect the like terms. 10 VA plus 2 VA 12 plus VA 13 VA minus 2 VB minus VB minus 3 VB, that should be equal to 80 minus 200, so minus 120. So this is equation number 1. And now we have to apply Kirchhoff current law at node number B. So again we can apply here because there is no voltage source and involved in any of the branch, so we can easily apply Kirchhoff current law. Again at node number B, we have to find that how many branches are connected. Actually 1, 2, 3, 4 and 5. This is outgoing current, incoming, incoming, outgoing, and outgoing. So at node number B, you can see that in 50 ohm resistance, this is incoming current. So we have to write down equation for current in this 50 ohm resistance. This will be VA minus VB divided by 50. Another incoming current is current in 100 ohm resistance, so this will be VA minus VB divided by 100, and all are actually outgoing current, so that should be equal to 300 milliampere, so this will be 0.3 plus current in 25 ohm resistance will be VB divided by 25 and plus 800 milliampere, so this will be 0.8 ampere. So now we can solve for we can see that LCM is 100, so we can multiply with 100, so this will be 2VA minus 2VB plus VA minus VB is equal 30 plus 4VB plus 80. So now we can collect the like terms, 2VA plus VA, 3VA minus 2VB minus VB, and minus 4VB, this will be minus 7VB, and this will be 80 plus 30, 111. So let's call this equation as equation number 2. So now we can solve equation number 1 and equation number 2 simultaneously. So we have actually VA is equal minus 14.27 and V3 is equal minus 21.83 volts. And because we also wanted to find the current in 100 ohm resistance, so current in 100 ohm resistance is VA minus VB divided by 100. So on this we can substitute the value for VA, that is minus 14.27 plus 21.83 divided by 100, so this will be 75.6 milliampere. So this will be the current in 100 ohm resistance. Thank you so much. So next we'll be discussing uh, mesh analysis. Thank you again.